My name is James Serra. This session is Deciphering Data Architectures, which is between a modern data warehouse, data fabric, data lakehouse, and data mesh. A little bit about me. The takeaway from this slide is I've been doing this quite a long time, 40 years in IT. I present a lot on this particular topic. At Microsoft, I'm a data and AI solution architecture in what's called the federal civilian area. So I deal with a lot of US government customers in there, but I've been at Microsoft almost 10 years now. I was prior in commercial. So it gives me a lot of interesting experiences with different use cases with all these different companies, whether they're large commercial or large civilian companies in there. And this topic has been a very hot topic, especially the last couple of years, with a lot of confusion with what is a data fabric, and especially with data mesh in here. This deck started out maybe 4 or 5 years ago, explaining a lot to do with data lakes and data warehouses and modern data warehouse. And of course, it's morphed with new technologies that have come out or new concepts. And I took this deck and made it into a book. So if you're interested in learning more and going deeper into what I'm talking about today, go and check out my book. So the agenda for today is we'll cover a little bit about relational data warehouse and the data lake, and then we'll jump into the architectures, modern data warehouse, data fabric, data lakehouse, and data mesh. I have to say these are my opinions, not Microsoft. I have the Microsoft shirt, but Microsoft does not have an official opinion on most of these things. It's whatever the employees for Microsoft think of these things. So other Microsoft employees may have different definitions or versions of these. I think they pretty much, what I explained here is pretty much what most people agree on, but it cannot be everybody. Feel free to drop questions in the chat. I'll pause along the way and answer them. And if I don't get to all of them during the session, I will certainly answer them after the session's over with. A lot of customers that I talk with, I think feel this way. They try to figure out all the data architecture stuff, and they feel like they've passed out drunk in a Denny's parking lot. So I'm going to try to prevent that from happening. It's a lot of confusing topics, and I try to explain them at a high level. So anybody, even a high-level C-level person can understand it. And I try to say that's because my mind is sort of simple, and I need things to explain to me at a high level before I deep dive into them. And that's what I try to do with this presentation. So jumping into the first topic, relational data warehouse, or RDW in there. I'm hoping most of us know what a relational data warehouse, so this may be a review, but the whole idea is you're trying to take all this data from various data sources. These are transactional systems or OLTP systems. They could be data entry, ERP, CRM systems. You're using ETL to pull all that data in a central location to do analytics and reporting off of that. The bottom line is you're trying to make better business decisions. And you're doing that, and doing that will allow you to get greater insights to your company. So you're taking all these different subject areas, creating a single version of truth in a data warehouse. Data warehouses have been around since the 70s, early 80s. And the benefits of a relational data warehouses have that single version of truth. A big idea is if I'm running reports on some production, some transactional system, they could overwhelm the compute and people can start complaining. So a data warehouse came around for the main purpose of copying that data and offloading those reports into the warehouse instead of doing it on a production system in there. That data can also be optimized for read access. You will run into problems if you try to optimize things for read access on an OLTP system when people are trying to write to it. So you can copy that data over and go crazy with read indexes on it. You can integrate multiple sources of the data to make those better business decisions. You can create the data warehouse so you can always go back in time and run reports. Even if data has changed, people have moved around the country, and those reports, if you don't have a data warehouse system, can reflect poorly on the current environment, on past environments based on changes. So data warehouse allows you to go back in time and generate reports very easily. You can take sources of the data, which could have very complex, hard to understand table names, field names, T116, 107 on there. If you're trying to do self-service BI and you have these table names that are confusing, it's really challenging. So you can copy the data over and rename the tables and fields to make it easier to do self-service BI. It can help against application upgrades. If you have reports going against the source system and you do an upgrade to some transactional system and it renames tables and fields, all those reports can break. So instead, if you copy that data into a warehouse, those reports will run against that warehouse. And if the source system upgrades, it won't break all those reports. Now it'll break the ETL going to pull that data over, but you just fix that in one spot, and then all those reports start running again instead of having to go through hundreds, if not thousands of reports and fixing them. With a data warehouse, it's one place where everybody goes to access the data, and you only have to give them access to that one spot instead of having to go and give them access to possibly dozens of source systems to run their reports, which can be very challenging. You reduce that to just one spot. You can keep historical data. A lot of times transactional systems, for performance reasons, will delete data. And if you go back and run older reports, you're out of luck in there. With a data warehouse, you can keep data forever. And so you can have all the historical reports. You can run them as often as you need. It's also a place in the relational data warehouse where you do master data management. You can build hierarchies on that stuff that's very challenging to do in a source or OLTP source system. You can plug holes in a source system. You may pull over data and you will find quality problems on there. Maybe a birth date field is having dates in the future, or people that are hundreds of years old, because the source system required that date to be put in there, and the entry person didn't know what it was, so they put anything in there. So you can, as you pull the data over, you'll start seeing these problems, and you can contact the people who are running the source systems and notifying them these issues, and then they can plug those holes. You still have to clean the data, but future data will be more clean. And then finally, because you do self-service BI, you won't need that IT involvement. And when I was in the IT, especially as a DBA, I didn't enjoy writing reports all day long in there. So build a system where the end users can run the reports and not bother IT people. Okay, so that's the data warehouse. A data lake, which is much newer. The idea of a data lake is to take all these different data sources. It doesn't matter what type or size or speed it is, and you can land them in a data lake. And that is defined as schema on read, meaning I don't have to do any upfront work to land the data in there. I can just copy it in there. It's like a glorified file folder on there, as opposed to a relational data warehouse where I have to do schema on write, where I have to define a database, tables, schemas, fields, and do all that work up front to land data in there. Also, relational data warehouse, you're limited to relational data. Here, you can put any data in there. It could be media files on there. So data lake is all encompassing and makes it very easy to center all this data in one place in there. So the reasons for a data lake, as I just explained, is schema on read. And that means I can put data in there very quickly. And if an end user is a power user and knows the technology, they can start pulling data out of there and generating reports and dashboards. This has changed a lot over the last few years you don't have to be a power user anymore. You can be pretty much any user, especially with things like Fabric, to go and start getting data out of there more quickly. It also allows you to investigate this data to see if it's even useful before you may want to go through the trouble of writing into a warehouse. I really hated it when I would do all this work, schema on write, create all this database and tables and fields, write the ETL to an end user who wanted this data, and then they would come back and say, oh, actually, this data is not helpful. Well, I wasted all this time in there. You can bypass that by blending the data in there quickly and then exploring it with the latest technology tools in there. The biggest reason I've seen for the data lake is if you have a data warehouse and that's all you have, generally you have a maintenance window. You cut people out of the system at night, you load in data, you transform it all, which is very resource intensive, and you do that into staging tables, and you copy that data into production tables, and then you let people back on, and you cross your fingers that you had no problems at night in there. And instead of doing that, think of taking those tables that are the short-term tables and putting them in the Lakehouse and copying the data in the Lakehouse and doing those transformations there, so you don't have to have a maintenance window anymore. And maybe the maintenance window is a few minutes where you copy that data after it's been cleaned, but that whole cleaning process happens inside of the data lake instead of in the staging tables on that. And that allows you to have a warehouse that could be run 24/7 in there, because you're not having to shut people off to do the cleaning of the data. So that was always been a big reason for a data lake on there. Also, because data lake is just storage, I can put whatever compute I want on top of that and have much more compute than I would have in a relational data warehouse, where you're limited to one type of compute. Here I can have huge clusters if I want, and they can generally save a lot of money because I can have compute that I can gather. Maybe I have a great deal with Databricks and I'm going to use that compute to clean the data. I can put, because data lake is extremely cheap, I can land data in there and keep it forever, even if I'm not even sure I'm going to use it. And that's another benefit of a data lake, which you never would do something like that in a warehouse. And then finally, you can keep all history of data in the data lake in there, even more than you would do in a relational data warehouse, because a data lake storage is generally multiple times cheaper than keeping data in a relational data warehouse. All right, let's jump. Thanks for the comments about reading my book on there. The modern data warehouse, the first architecture. At a very high level, modern data warehouse has both a data lake and a relational data warehouse. This has been around for maybe ever since data lake came around, maybe 10 years ago on that. And this is slowly getting out of favor with the newer architectures, but it's important to understand there's a lot of architectures built using both data lake and a relational data warehouse on there. And all the processes and the architectures I'm going to talk about follow the same patterns. You ingest, store, transform, model, and visualize. And those 5 steps, other architects may call them something differently, but they're all going to follow that same pattern for copying data along the way, in the end, to make it visualize and have those better business decisions on there. And if having both a data lake and a relational data warehouse at a high level, these are the best features of both in there and the way they're used. Think of the data lake as your staging and prep area where you're doing all that cleaning of the data. You can also quickly explore the data, maybe do one-time reports. It's also great if you don't really know the questions to ask, because I can put that data in there, look at it, and think of, okay, now I come up with some idea of maybe I want to create a report, a dashboard of this as I'm exploring that data. The relational data warehouse has traditionally been that serving security and compliance layer. It becomes a serving layer because many of the tools have historically been using a relational data warehouse, and you can continue using them instead of trying to make them work for a data lake. It's a security layer because traditionally the data lake has not have a lot of security built in, like some things it still doesn't have in its native format, like row level security. So I have all these additional security on a relational data warehouse and compliance areas in there. So relational data warehouse is great for the business people to access. If you need low latency, because you can use technologies that make reporting and querying much faster than from a data lake. And it's a great place when you know the questions to ask. You can quickly build data. You can build reports and dashboards from it. So if I dig a little bit deeper into what a modern data warehouse is, this is what it looks. These are the 5 steps. You're ingesting sources, and this is a batch-oriented architecture. So you're ingesting these sources maybe once a night or once every hour or so into a data lake. The data lake made up of a medallion architecture, multiple layers on there. I call them raw and clean in the presentation. Within those, there's the various folder structures in there. There's some great sessions earlier that talked through this. This could be a very long topic of data lake design, but the idea is to land the data in here in a way that's easy to clean it and then put it into presentation layer where it's really easy for people with the technical know-how, especially data scientists, to go and start building reports and dashboards off that, or to do machine learning off of that data as it sits in this file folder structure. Traditionally, you would still copy some, if not all of that data into a relational data warehouse because that's your serving layer. The data could be copied in there in third normal form, which you can then copy again into a star schema to make it easier for people to do step 5, visualize the data, do that self-serving piece of it. So as you're going through here, there's more copies of the data. It's more complex, more cost, but in the end, you have data in a way that is easy for self-service BI. So that's the whole idea, is go through the work, for IT to go through the work to make it easy for the end users to build reports on their own and not get IT involved. So that's the first architecture. The next one is the data fabric. What is the data fabric? This is where my view may be different than others in there, but I view data fabric as an evolution of what I just showed you, the modern data warehouse in there. It's adding a bunch of additional features that make it a fabric where it can go and weave out like a fabric and pull in data from an organization, no matter what the size, the speed, and the type of the data. Well, to do that, you need more features on there. So things like real-time processing on there. You may want to have more security on that. You may want to have a metadata catalog so people can see what kind of data is in this architecture in there. This is where a data fabric would get into master data management. It may use data virtualization components in there. It may create APIs for accessing the data. And you may build this out in building blocks and services where maybe I create a great ingestion piece in this fabric, in this data fabric, and somebody from a company says, well, I don't really need the data fabric, but I love that ingestion piece. Can I use that for some other project? And if you build it in building blocks in there, then they can definitely use that. So the bottom line of data fabric is just giving you access to more data, making it more secure, and making more data available. With the idea is you never have to say no to an end user who says, I want you to add this data to your architecture. If you built it out right with this fabric, you can say, no problem, we'll ingest that data. What does the data fabric look at a high level? It's adding these features in purple compared to what the modern data warehouse is there. Getting into the advanced security, master data management, maybe creating APIs and having the metadata accessible in here, and also adding a real-time component to it, which could involve a number of new products in there. Diving a little bit deeper into this architecture, this is what it looks like. So now I'm adding, it's just like the other one with the same 5 steps, but now I'm adding additional functionality. I have a real-time ingestion piece on there. I've added APIs on there. I've added a metadata catalog like Microsoft Purview on there. And this gives you that fabric to pull in any data no matter the size, the speed, and the type. All right, very fast. Data fabric has been around for a bit now. This is evolving into the next architecture, which is where we get into the Microsoft Fabric, and that's the data lakehouse on there. So again, dump in any questions you have into chat, and I'll be happy to answer them. All right, data lakehouse. I always like to start out with just a couple of minutes of a historical perspective. Some of you, if older I am, you remember the data warehousing in the late 80s. That's when I first got started in the mid 80s, and data warehouses back then, something like a Teradata, a Leda, and a Netezza, were all encompassing. You buy the product, you get relational storage, you get the compute, you get the reporting tool, you get the ETL tool, and you build out. Of course, everything was on-prem, and you build out this cool data warehouse that handled big data. Back in the day, big data was, I remember, like a gigabyte, which is crazy to think of now, but you needed special solutions to handle the big data. And this worked great. And we still have customers that I deal with at Microsoft who have on-prem data warehouses and solutions. Almost all of them are trying to migrate, but it's still around. And in a lot of cases, they would use the data marts, where they would take the enterprise warehouse, would have all the subjects, and they would copy them into data marts for specific subjects, for specific use cases in there. And this gets into the whole Kimball and Inmid methodology, which is a whole other separate topic in there. But then in the late 2000s, not that long ago, came the data lake. And this was, people thought, the holy grail of, I can just do everything with a data lake. I don't need data warehouses anymore. I can land data in the data lake. They can do everything that data warehouses could do. That failed miserably. And it was mainly because data lakes were too complex technology-wise for people to understand it on there. Imagine trying to tell an end user to go use Hive SQL back in the day. And so while the data lake as an all-encompassing solution failed, it was recognized as still useful for certain purposes, just not everything. The main purpose being what I was talking about with the modern data warehouse is use it for transforming the data. So the modern data warehouse came out saying, let's use some features of the data lake, but still using the enterprise data warehouse in there. So we're using both. And then that morphed into the data fabric to have more capabilities. Well, around 2020, the data lakehouse came about. That was combining the cute way of combining a data warehouse and a data lake into that term data lakehouse in there. And the idea of a data lakehouse was to do everything in a data lake, which I just said it failed. So what's changed since then? What's changed is the Delta Lake functionality that Databricks came out with to make your data lake relational data warehouse like by adding additional features on top of it. So you could, in fact, do everything within a data lake. So Delta Lake was the big change. And Delta Lake is not its own storage. It's just software on top of an existing data lake, giving it the relational data warehouse like features in there. If I'm using Spark, I would just save it. Instead of saving it in, say, Parquet or CSV, I can just save it in Delta format, and I'd have all this functionality. Some of the functionality would include the ability to use SQL commands. If I have a data lake, it's just a glorified file folder. It has no idea what SQL commands are. But with Delta Lake, that transaction layer allows me to do SQL commands on top of data files that are sitting within a data lake on there. I'll also have ACID transactions for one table, which could be extremely helpful. It gives me features like time travel, so I can do versioning of data as it lands into the data lake on there. It's a place where I can do both streaming and batch without changing technology. I can do everything within, say, Databricks on there, whether it's once a night or multiple times a minute. It has features like I can enforce schemas in there, so my ETL is not blowing up if somebody dumps a bad formatted file in there. And it gives you many performance improvements, dozens of them, a couple listed here. So this can make Delta Lake allow you to do queries much, much faster than just going against a data lake in there, to make it not as near as a relational data warehouse, but fairly close. And then if you're familiar with the small files problem in there, Delta Lake gives you options to optimize command to overcome that problem, which heavily influences performance. So a data lakehouse at a high level architecture would look like this. It looks just like the data fabric, except I removed that relational data warehouse piece. And that becomes a relational serving layer, which I'll talk about in a minute in there. So this means I just have one place where the data is copied, and that's the Delta Lake format in yellow that allows that to give all the additional functionality. So the use cases for a data lake are fixing 6 problems you usually see within a modern data warehouse in there. If you have 2 copies of the data, you need to keep the data warehouse consistent. And ETL breaks copying from a data lake data warehouse, now you have a reliability problem. With a data lakehouse, you have 1 copy of the data, that problem goes away. 2 copies of the data means even if I'm running it, say, every hour, copying it from a data lake to a warehouse, the data is older, and that can cause problems when people get different answers if they're going from a data lake compared to the relational data warehouse in there. 1 copy, that problem goes away. Usually, a lot of the data scientists prefer a file and folder format and not a relational data warehouse in there. So it gives you additional support for advanced analytics because of that file folder format in there. Even though data storage is very cheap, you're still saving half the cost because you only have 1 copy of the data. If you have 2 copies of the data, it's more exposure to hackers. 1 copy reduces the risk. If you have both a data lake and a relational data warehouse in there, you need people that know both, or you have to hire people that are experts in one and the other. I'm getting rid of the complexity, cutting it in half, so it makes me easier to hire people that could build a solution. So what that looks like, if I dive a little deeper, is, again, it's just like the data fabric, except that relational serving layer is a is a piece on top of the file folder format structure with the idea of presenting the data in a relational format so end users, it's made easy for them to go and query that data or build reports of that data. If you went to them and said, hey, instead of a relational layer, you now have files and folders, that can get very confusing for them to continue generating the reports. Not only that, but their tools may break. I can have a relational serving layer on top of it. That could be a view, a SQL view that points to a folder in there. There's a lot of ways of creating the relational server layer in Power BI. That would be a semantic model. So the end user would actually think that they're going against a relational data warehouse in there because it appears the same to them, but when actually it's just a relational serving layer. And the important point is that serving layer is not a copy of the data. It's just a software on top of that. All right. And we got a question in there, is a bronze, silver, and lake. I think the question is if you're talking about a Microsoft Fabric, those can be lake houses or they could be warehouses in there. So in the medallion architecture, this is kind of a little bit off topic, but I could, for the raw layer, I could make raw, clean, and presentation all lake houses or all warehouses. That gets into the main differences between a lake house and a warehouse is how you are writing the data. If I want to use T-SQL to write the data, I have to use a warehouse. If I want to use Spark, I have to use a lakehouse. What I see is many customers, usually they have the bronze and the silver layer are lakehouses because they like to use Spark to write the data. And then the presentation layer becomes a warehouse because their end users like to write data using T-SQL. Now, a lot of times there's combinations. They may have both a lakehouse and a warehouse in the presentation layer that has the same copy of the data just to support all different users on that. All right, so thanks for that question. Keep them coming. So I've explained the data warehouse in there, but I'm going to open up a can of worms because there are always trade-offs. And I went in my book into a lot of the trade-offs between all these architectures. With a relational data warehouse, the speed, queries will never be as fast as a relational data warehouse, especially if you get an MPP technology. It doesn't have things like advanced indexing, statistics, caching, and other stuff listed here. So if you need this speed for ad hoc queries, you may need to go to a relational data warehouse. Delta Lake does not have row of security, column of security. So if you need those things listed here, you may need to go relational data warehouse. Now there are workarounds for all this. For example, I could copy that data into Power BI because Power BI has row of security. So that's one way to work around of that. So a lot of technologies that have come out now, especially in Fabric, address most of these concerns, but you should still be aware of them. And you can say, look, I'm not using Power BI, so I can't use some of the workarounds you're talking about, James. People are used to using a relational data warehouse because you have this forced metadata on there, and this deals with these two points. A relational data warehouse, I have to put in the schema on right. I need to put in the database and the tables and the fields and the schema, and then I add in the data. In a lakehouse, even using Delta format, I could land data in there, but where's the metadata? I don't need to have metadata along with the data. Maybe I have it and it's the first row in the CSV file. Maybe it's in a separate file, but it cannot even exist. So this is a challenge on there. And there's no easy answer to this other than to have best practices to have the metadata somewhere that's easily findable on that. But that's something that's very different. And so sometimes the extra work of forcing a metadata layer in a relational data warehouse could come up with a solution that's easier to use than something in a Delta format. Concurrency can be slow if thousands of people are hitting the same file in a Delta lake. Again, a workaround would be copy that data into Power BI so you're not having that problem. There's a lot of missing, not a lot anymore. There's a few missing features, I'll say, within Delta Lakehouse in there. For example, SQL views don't exist in there. There's no referential integrity. If these things are important to you, then you may want to look at a relational data warehouse in there. And also, if you're using a Delta Lake, well, then products need to support that, which most in the Microsoft world do. So this is less of an issue. The bottom line is, if you have certain data that has a problem. Maybe I have billions of rows in this particular set of files in there, and Delta format is just too slow. Well, you can copy just that particular data set into a relational data warehouse, and you can make all the other ones Delta format in there. So you can have these exceptions, but it doesn't mean it's not an either or thing on there. Okay. So questions. John, hey John, we've known each other for a while. How about row-level encryption? I find there's not a consistent method between Lakehouse, warehouse, and semantic model. Something to put on the wish list. Yeah, I'll call Satya on my red phone and get that done in there. There's a lot of trade-offs with Microsoft Fabric, a whole separate conversation of there, but that is where we want to use the Microsoft Fabric is Lakehouse. Using Delta format, everything is put in there. There is no relational data warehouse like there was with Synapse, where you had a dedicated pool. That all goes away. So you have to be aware of these trade-offs. Many of these, but not all of them, have gone away with Fabric in there. So you always need to keep that in your mind, back of your mind. All right. So 11 minutes to cover data mesh. And here, data mesh, let me explain it at a very high level. John Degani created the concept of a data mesh, which there weren't really any new ideas in there. They were just packaged together really well. But she, in my opinion, made it very confusing to understand a data mesh. And it took me a while to read your blogs over and over again before I tried to simplify it into this slide. All the architectures I talked about previously, the three ones of them were, I'm copying operational data from domains, which could be HR and finance, copying the operational data into a central solution where I'm then creating the analytical data. Data mesh does not do that. There is no copying of data into a central location. Instead, each domain is now charged with taking its operational data and creating analytical data from it. So each domain now has its own analytical data, which can be built using MDW, Data Fabric, or Data Lakehouse. So they're not mutually exclusive. Domain A could have a Data Lakehouse, B could use a Data Fabric on there. But each of those domains has to make it easy for others to access the data. So if somebody comes along and says, I need data from multiple domains, they could do that because each domain is making their data available as a product and has what maybe it's API calls to get access to their data. So that's the big change. But a data mesh is a concept. It's not a technology. It involves a huge organizational shift, big cultural shift, which is why many customers do not try to build a data mesh because there's too much of a change. And there's been this misnomer about data mesh is very easy to build. It's the opposite. It's very hard to build things in a data mesh. There's no magic wand you can buy in eBay. And so up front, you have to realize if you're going to go a data mesh route, it's going to take you a lot longer to build a solution. A data mesh it's made up of 4 principles. Try to explain them in a couple minutes on here. I try to simplify them. And the first principle is ownership. The idea is the people who own the data are the other domains. Instead of copying the data into a central location where IT owns it, or arguably the domains can continue to own it. Now there's no argument. IT owns nothing in the data. All the domains own their data. So you could have manufacturing, supply, sales in there owning the data. And the idea is they've known the data best and they can clean the data and make it easier to use because you're not entrusting IT to learn about the data and to clean it in the right way. Principle 2 is data as a product, meaning each domain is going to take that operational data, create the analytical data. Well, to do that, they're going to have their own teams. So they have their mini IT teams. They're going to take their own infrastructure. They're going to they're going to have their own compute, and they're going to build out the analytical data. And then they're going to make it available to others, which is data as a product. So anybody wants to access the data, it's going to be easy because they've maybe followed some contract that all the domains are following to make it easily available. Maybe they all create APIs on that. Well, to do all that is a lot of work. To make it easier for each domain to build a solution is worth principles 3 and 4 come in play. Principle 3, self-service data infrastructure as a platform, is the idea to simplify building of a particular domain. Ideally, you have a script, you just click a button and it says, what do you want to name your domain? And it creates all of the storage and compute and ETL and security. Well, no tool does that, not even close. And so most customers are building their own. But the idea is I don't have to go tell a domain node, do things from scratch. I'm providing some scripts or other technology to make it easier for them to build. Also, along the same lines is federated computational governance. The whole idea is I need to create some global rules that all the domains are going to follow. So when they build their solution, it's easy for others to grab data from all these different domains. They need to you can't have one doing completely different security than another. You can't have them cleaning it completely different ways than the others in there. So the governance is a playbook for all the domains to follow to make sure their solution is presented in a way that's easy for everybody to use. So a data mesh architecture, this is where it gets confusing. It's not all decentralized. 1 and 2 principle are decentralized, but 3 and 4 are usually built by centralized teams to present to everyone else. So you can't have everything decentralized. So those centralized teams could actually be made up of people from all the domains in there, but there's going to be a central group that's going to create those scripts and it's going to create the governance that all the domains are going to use. So the use cases for a data mesh are solving 4 challenges. The lack of ownership goes away. All the domains own that. The quality is improved because the domains are cleaning the data. But the 2 biggest things are scaling organizationally and technically. If I have more domains, each of those domains hire more people, so I can scale out and not have IT be a bottleneck where it gets backed up, where they say we don't have enough people to keep up with all this data. That at least in theory goes away. And technical scaling, each domain is having their own technical creating their own infrastructure. So the more domains, the more infrastructure it is. So I'm avoiding the problem of IT becoming that bottleneck because the infrastructure can't keep up with it. And a big challenge with a data mesh is dividing things out in domains, and within domains you have products. An example would be something like this, where healthcare has 4 domains. Each of those domains have multiple products in there. This is where a lot of customers have struggled because their organization may not be domain oriented as it is. So this requires a big cultural shift because now you're also moving people around into these domains in there. So there are a lot of concerns with a data mesh. I go into detail in the book on them. I just have a few here to listen. I don't have time to go over all of these, but you can imagine the challenge culturally of having that. The idea of each domain implementing things technically different could be very challenging in there. There's the performance problems now come to mind of I could have dozens, if not hundreds of domains, and if I come along and I say I need to ingest or combine data from multiple domains, that could be extremely slow. So that's why 99% of companies that I deal with do not build data meshes, but they are being built, and the ones that are being built score high or medium on all these categories. This is actually from Jamek's book, and I find 99% of the companies are not scoring high on these lists in there. They're not tech at core. They are not on modern engineering. They're not already domain oriented. So this is where what winds up happening was people look at the data mesh principles and they may say, this all sounds great. We can't build a data mesh, or at least a pure data mesh, but I'm going to borrow 1 or 2 of those principles and use those principles within the other architecture I'm going to build. Maybe it is a data lakehouse in there. So what I'm seeing is for those building a data mesh or something like a data mesh, they usually start out with a couple of domains where they get new data and they build out those mesh components, but they have all the centralized data that are not mesh. Now, maybe over time they move some of that out into mesh, but you'll never get everything out into data mesh. It's extremely unlikely because all it takes is one domain to go like, I'm not building a data mesh. I can barely keep things going up as it is. If you want that data, take it. Well, you need that centralized data solution in there. So the concepts are great, and I'm glad it came about, but understand most, if not all, customers are not going to build a pure data mesh. You're just going to take bits and pieces of it. So when they use architecture, if I still see customers using a modern data warehouse, if they have a small amount of data, and if they're using a relational data warehouse, you can even skip the data lake if you have very small data. If I have only a couple of gigabytes, I may say, well, you don't even need a data lake. But be aware, what you have now is going to likely increase greatly in the next few years. So you may want to think ahead and jump into another architecture that uses a data lake. And so there's other kind, like a data fabric. I find this happens a lot if there's a migration effort of something maybe on-prem and you have hundreds, if not thousands, of stored procedures. It could be hard to migrate into a lakehouse because those stored procedures would need, pieces of them would need to be rewritten to work against a lakehouse architecture, a Delta format. And John just touched on this in this prior thing, is some things don't work in there. So you could avoid the rewriting things by just keeping with the relational data warehouse. Generally, I say with a data lakehouse, build it until you can't. So start out with Fabric. If there's a situation where a data lakehouse, a Delta format doesn't work well, then you copy that piece of data into a relational data warehouse and go forward that way. And then finally, a data mesh is only if you're a very large company, you're having major pain points, and you have a very long timeline, because it could take years to build out a data mesh in there. And each of those domains, to reiterate, we'll use a modern data warehouse, a data fabric, or data lakehouse approach in there. So it's going to be a combination of the two. The bottom line is go and look at your use case, learn about all these architectures, and take the bits and pieces that's going to work better. I do a lot of architect design sessions, and it's always different with customers what the architecture looks like. And so build out something, but you don't know what you don't know. So dive more into these architectures and then see what's going to work best for your use case. And the final thing I'll add is, if I am going to take a data mesh approach and I want to use Microsoft Fabric, Dennis gave a great session prior on doing this. What it all comes down to is I'm going to have exceptions to a pure data mesh. I have customers that have so many exceptions, I won't even call it a data mesh. I'd call it a data lakehouse with many workspaces. But you want to call it data mesh, fine. If you're going to use Fabric to build it, this is where a lot of exceptions come into play. A few listed here is, you're not going to go to each domain, and each domain is going to use Fabric. The pure data mesh says each domain can use whatever technology they want. So you're having this one big exception. Fabric, as Dennis pointed out, instead of using what a pure data mesh would be is API calls, you're using shortcuts to that. And then the final thing I'll talk about is, if you're using Fabric for a data mesh, it doesn't enforce the principles. I can create a bunch of workspaces that have nothing to do with domains and just plot them underneath a domain and say, look, it's a data mesh. Well, it's not. So you have to do a lot of what I mentioned before. Is it's a concept. You have to really embed everybody with the data mesh concept, and they follow that when they're building out a data mesh using Microsoft Fabric. All right, cool. So that's it.